Okay, finally, question 2c asks us to multiply out the following brackets. So we have 5x plus 2y into x minus y plus 1. We've got quite a few terms here, so this one is a little bit more of a slog, but as usual it will help to add in these arrows that in turn will assist us in breaking the brackets. So we have one arrow here, but now we have an extra term, so we'll end up with a third arrow that we'll have to treat. So we have 1, 2, 3. Similarly for the second term in the first bracket, we have one arrow, and another arrow, and then another arrow. So that gives us 4, 5, and 6. We'll use that to help us break the brackets. So for the first term we have 5x times x, that's otherwise known as 5x squared. For the second term it's 5x times minus y, which we'll write as minus 5xy. Then for the third term, 5x into plus 1, that's simply plus 5x. Okay, arrow 4, 2y times x, we can write that as 2yx. Then 2y into negative y, that is known as 2y squared. And then finally for the sixth arrow, 2y into 1 is simply plus 2y. Okay, now we'll use the same trick that we did in the previous question, part 2b, and use the observation that multiplication doesn't see order. So xy is equal to yx. So in particular that will give us that the previous line is equal to 5x squared minus 5xy plus 5x. And then the next term can be written as plus 2xy. And we have minus 2y squared plus 2y. We need to keep track of things to make sure that we have collected all of our like terms. We start off with the 5x squared term. There are no other terms in x squared, so we'll write that as 5x squared. But now we notice that we've got two terms like xy. We have a minus 5xy or negative 5xy and a plus 2xy. Minus 5xy plus 2xy is overall negative 3xy. Contribute that there, and if you like, along the way you can score off the terms that you've treated. Next we see there's only one term in x, that's plus 5x. We notice there's only one term in y squared, that's minus 2y squared, and we notice there's only one term in 2y, and that's plus 2y. I would say that that is the expression in its simplest form, and we will stop there.